Thanks for coming. So let's talk about building microservices with Java EE and MicroProfile. I know it's the hardest session of the day, probably, right after lunch. So bear with me. I think it's kind of exciting, so I hope you don't fall asleep. Stichwort Fressnarkose. Yeah, so let's get started. Just briefly about me, my name's Leander. I work in Munich, I work for Coavia. For some unknown reason, I submitted this talk in English. So bear with me, because I'm going to speak English for 45 minutes. Yeah, I'm a developer and architect for, more than 20 years. I'm 41 now. I had my first job as a Turbo Pascal programmer at the young age of 15. So I'm programming for quite some while now. I've been programming Java for, since version 1.0. At some point, I was fed up with implementing double linked lists in C++, and then I figured, well, let's go for something, for a nice language. I'm a cloud native nerd. For like the last 4 years, I've been, implementing various systems for large German customers like, BMW, Allianz, and building cloud native, highly distributed systems. I'm a big fan of open source. I'm a speaker and author occasionally, and also I'm a teacher at FH Rosenheim in cloud computing. So Twitter handle, email, GitHub stuff. So who wants to code along? Is there anyone in here who wants to code along? Because I've prepared everything on GitHub. You find all the source code I'm going to show you now is available on GitHub. So then you're going to see this page. Mind what I've done, so I've prepared a couple of branches, right? So those are kind of the different steps we're going through. So in case you want to have some homework maybe, or if you want to see how I implemented certain things, feel free to copy this stuff, okay? It's MIT, so you don't even have to mention my name. Excellent. So, Christian, now comes your part. I want a picture of this slide. Microservices. Yeah, we have to talk about microservices now for just a while. I know this is a pretty vague term, and I'm sure you all heard of microservices. Hands up who hasn't. The unicorn is not here. Anyhow, so not a clear definition, right? I mean, microservices ought to be autonomous. They ought to be message-driven. They ought to be loosely coupled, stateless. Sometimes you read articles where they argue about the proper size of a microservice. People making jokes saying like, if it's more than 5,000 lines of code, then it's not micro anymore, then it's a macroservice or something. Yeah, to all fairness, I mean, different definitions, different people. What I want to do is I want to give you my definition. I'm a software engineer, okay? And no matter if you do an agile or if you do waterfall, I think we all go through this software development lifecycle, right? We need to implement the feature. Then first up, we're going to design the feature somehow. Maybe we take, a pencil and draw a few lines and boxes. Think about how we implement things. We think in components, right? So this is like the term I grew up with. So components are our complexity unit, data integrity units, and feature units. And they're also my, decoupling units. What I do next then? Well, I'm going to develop my components. So I have my dev components. So maybe I use, Maven, maybe Gradle. I do like multi-project type things. So I'm going to implement my design components as dev components. Now here they become my planning unit, my knowledge unit, and development and integration units. And the one thing that, in my opinion, is kind of new in microservices, or really new, is the ops component. I mean, what did we do previously, like 5 or 10 years ago? Well, we stuck all our development components into one huge runtime unit, and there we had it. That was the monolith, okay? We had a monolithic deployment. So we don't do that anymore, right? So we choose wisely based on domain-driven design principles, maybe how large are my individual ops components? Which of my dev components do I stick into a microservice? This then is my release unit, my deployment unit, and most importantly, my runtime unit, okay? So if there's something crashes, only certain parts of my system are not working anymore. If something slows down or I have an access issue, then only those certain parts of my system are kind of, inhibited. Also my scaling unit, right? So this is all there's to it, in my opinion, okay? fancy name microservices, but in the end, it's just a few components stuck into an individual operation component, and there it is. Now, if we want to design microservices, there is definitely a lot more than just doing Docker, right? I mean, you have your WAR file, like we've seen with Adam's keynote. You take your WAR file, you stick it in a Docker container, you run it. Is that a microservice? Is that a real enterprisey microservice, a real enterprise cloud native application? I wouldn't think so. So what you have to do if you want to design proper and implement proper microservices, there are some essential design principles you have to adhere to, and maybe even more than you used to do. So design for distribution, of course. You will run in a container, and you maybe want to apply API-driven development. Design for configuration is important. So what you want is you want one image, and you want to run this image in multiple environments. Your int, your QA, your pre-prod, your prod environment. Design for resiliency. Of course, in a highly distributed environment, all things fail all the time, right? So your system should be fault tolerant and self-healing. Elasticity, quite important as well. So your system should scale dynamically and react to stimuli. And this is kind of challenging, right? If you have a stateless technology, a stateful technology, maybe JSF, for example, then this is kind of hard, right? Where do we put the state? How do we handle the state? Design for delivery. What you want is short round trips and automated provisioning, right? If the product owner tells you, well, we need to implement the feature as fast as possible and we need to be live in 2 weeks, your whole development process needs to be tailored and streamlined. So short round trips and automated provisioning becomes essential. Performance, again, responsive, concurrent. You want to be resource efficient. Maybe that kind of changes the way you implement things. Maybe you adopt a more reactive programming style at that point. Design for automation. So you want to have automated dev and ops tasks, and they don't come for free, right? I mean, if you want to automate your system, you need to implement certain, well, ops endpoints maybe, so your application can be automated in the first place. Diagnosability. A super challenging bit. You want cluster-wide logs, cluster-wide metrics and traces, right? Debugging the good old monolith, that was that easy. You fire up your IntelliJ, you attach your debugger, and off you go, right? But how many debugging sessions do you want to have open in a distributed system, right? Your system needs to care for this diagnosability as well. And last but not least, important, security. You want secure endpoints, API gateways, end-to-end encryption, all this sort of stuff. Now you see lots of design principles, and now the question is, what type of technology do we use to implement systems that that can adhere to those design principles? And what I show you here is what I call my personal microservice blueprint, applying Java EE 8 and MicroProfile in this case, for today for this session, right? You have the first bit, of course, your microservices need to communicate, so you need to some form of service exposition, either using REST APIs or maybe messaging. You need to have a way to discover the other services, so service discovery becomes important. And if you have synchronous service invocation, then of course resiliency is important. Next up is configuration and coordination. It's like a separate block, right? If you have the cluster of moving parts, you may need to coordinate between those, right? And you need to configure those. Data management. So how do you handle persistent data in that case, right? And also the elasticity part. What do you do with the state? How do you distribute the state? How do you handle the state in your system? Security, and last but not least, we have the diagnosability bit, tracing, monitoring, and logging. And the good part is, Java EE 8 in combination with MicroProfile does have an answer to pretty much all of those. And that's great, right? So, Java EE 8, here's a quick overview. Don't mind the colors. Well, first up, left-hand side, JCON2018 officially not part of JEE, but well, let's pretend it is. It would be. Maybe it is in the future at some point because it would be great. So you have CDI 2.0 now with Java EE 8, mainly adding asynchronous events, so you can do like message event-driven based programming within your system, which is, I think, pretty cool. You have Servlet 4.0, JuxRS 2.1, JSON-P 1.1 with the JSON patch API added, JSON-B 1.0 finally, so JSON binding API, so no need for explicitly depending on JSON anymore, so Java EE can do this for you now. Yeah, EJB 3.0, JCA 1.7 to maybe connect to some message queue, JPA for persistence, JMS for messaging, a new bean validation API, and also the new security API. So I think a solid foundation to build enterprise-grade microservices. Well, unfortunately, or maybe not unfortunately, I don't know. What you see here, there's no API covering almost any of the, well, let's say, cloud-specific design principles. And this is where MicroProfile comes into play, okay? So MicroProfile at the moment, version 2.0, with nice JE8 integration. The slightly younger brother or sister, I don't know, is 1.4. So what do you see here? So you have Open Tracing API. So you have like the diagnosability part covered. You have Open API 1.0, that's for documenting your APIs. You have REST Client 1.1, so this is typed REST client stuff. So finally, you can have like a Java interface and access remote well, parties using a typed interface. You have MicroProfile config 1.3, fault tolerance for your circuit breaker. Adam showed some of the stuff today. You have the metrics, you have job propagation, which is for security. So you have your good old JSON web tokens for security. You have an API for health checks. And then at the bottom, basically, you see the bare minimum of JE kind of, APIs like CDI 2.0, JSON-P, JuxRS, and JSON-B. And the good thing now is, and Adam told us in his keynote today, that the good thing is that most of the current, runtimes, app servers in this case, support both of them, okay? Not fully, as we've learned, right? But Payara, for example, does. I mean, this is kind of the app server I'm working with the most, because my main customer, BMW, has like, Payara in the backend, and it's a dead cool app server. But no offense, Open Liberty, Wildfly Swarm, Apache Tommy, they're all good, okay? So pick the one which is kind of suitable for your enterprise or for your project or whatever. So I'm not going to vote or judge on any. But Payara is a good choice, definitely. So they're all cloud ready, they're all small, they have a small footprint, so the times are over that, things are like, JE, ooh, so heavyweight, right? I mean, those times are long over for 4 years, 5 years at least. So, well, to implement a small microservice, what do you start off with? Well, you probably start off with this code here. What you need is some JuxRS configuration which extends application, you specify the application path, and then you're going to implement your first Hello World resource. And that's kind of the place where I say, well, let's make it a bit more entertaining, and let's switch to code, right? Because I don't want to bore you with slides that contain code. So timing looks good. So what I've done is, right, I've prepared a JCON markdown README file. Okay, so if you want to follow along, all the steps and all the samples I'm going to kind of copy-paste code now are in the markdown. So first up, what do we need? Well, let's add a few dependencies first. As you see here, I'm going to use Gradle. My main, let's say my main build tool is Gradle nowadays and not Maven anymore. But hey, if you have a working Gradle build, then that's not that bad at all. So we add a few dependencies. As Adam pointed out, there's this one seminal dependency, JavaX, Java EE8 API 8.0. This is all you need. Later on, we do some caching stuff, so I'm going to add this kind of optional dependency on the JCache API as well. So what do we need? Well, let's implement, we already have it. So that's like the JuxRS configuration class. We extend application, and we're going to annotate it with application path. So all my REST resources will later then be found under /API/something, right? So this is what the application path looks like. If you're not going to override any methods in here, then the default component scanning will kick in, and this does work most of the time. So don't override any methods in here for now. So next thing we do, well, let's implement our first hello REST resource. We're going to hello world resource. No, don't add. Up. So we need add path. We are going to return a JSON object. JSON object in that case is part of the JSON-P API, which is kind of a neat way of well, constructing programmatically constructing JSON objects. Those imports, system get env nullable, and we're done. Okay, I mean this is obviously the super small hello world program. We get some environment variable called hostname in this case. If it's nullable, we say localhost, and we're going to construct a JSON object. We say add, and then finally we call build. I think JSON-P is kind of nice, you know, for this type of thing. I don't want to implement a stupid POJO, right? I mean, I could, but it's also convenient to just create a JSON object programmatically in this case. So this is, well, this is almost it. This is hello world done, right? Not much here. I could show you, well, where is it? Where's my kind of HTTP get localhost 8080/API/hello, right? There we go. So we have the host name because we run in a container in this case, and we have the message. So not so super exciting at the moment. So let's start with MicroProfile. So let's add some sugar. I know Adam said, well, there's this, you know, this MicroProfile bomb, and it's kind of easy in a Maven world. So in a Maven world, you would kind of add this dependency here, but Gradle unfortunately doesn't have bomb support. So I'm going to use, where is it? Gradle build file. I'm going to add those dependency here, and I think it kind of makes it also pretty viable, right? So you have the first one is the config API, the metrics API, the health API, the open API for documenting, the typed REST client for fault tolerance, job propagation, open tracing. So those are individual dependencies. And I mean, this is probably up to the architect, maybe responsible for the system. I kind of prefer to kind of reduce the amount of APIs which should be used in a system, and I like to control it. So I'm kind of more of a fan of specifically specifying the dependencies you require. Right, so let's continue. Now, we've learned configuration is important. So let's add a configuration bean, right? So we create a Java class, we call it hello configuration, and we do this here. Now this is the first usage of a MicroProfile API. Adam also said, well, it goes through this standard add inject, and we need an application scope here, and we're done. So what do you have with one concise API, which is the config property annotation, which is here we want to look up the host name. So basically what it does, it looks for a hostname environment variable, which we hopefully all have. System properties, then there is a default meta-inf microprofile config properties file as well. So those are the default sources where your configuration values are looked up. And it's good practice in cloud native applications to, well, kind of use environment variables anyway. What you can do is you can inject standard types like strings, longs, array of strings, you know, like all standard types directly. What you can also do is use the add provider interface, and this is kind of a dynamic lookup of this configuration value. I mean, for the host name, it's not going to change during the runtime, right? So it's okay to inject the bare host name in this bean here. Maybe for a message, which may need to be dynamically configurable by some maybe Kubernetes type config map, then it's kind of convenient to, well, inject a provider for this string, and then here in the getter method, you then always issue get. So this will always perform a live lookup of the value. So if it changed in the background, then you will always get the live the live value. So maybe that's kind of useful, maybe for dynamically configuring any circuit breaker timeout values. You kind of realize, oh, that's a bit too short. Then you kind of tweak it during the runtime without restarting your container. There are other ways of doing this here. As I said, what you can do, for example, you can have a string array, for example. So what you do with this, that's a Mac, not a Windows. Don't do Windows Q. So that's not good. Config property. So if you do name here, I don't know, an array. So the good thing is, for example, what you have here, what you can have here is like A, B, C, D. So it will automatically do like the parsing for you, the splitting on the comma for you. So there's a lot of convenience here. If the convenience is not enough, MicroProfile gives you the opportunity to implement various converters for non-standard types. It gives you the opportunity to have like different config providers and config sources. There's a lot of extension stuff possible whenever you say, oh, I'm not going to, the default stuff is not enough for me. Okay, so that's configuration done. So what we could do here within the within our bean, right? So here's the resource. So what we can do in here is like, I don't know, private hello configuration. We're going to inject it, and here we say configuration.get hostname in this case. And here we can say configuration.get message, right? And we can get rid of this one, and it looks a lot cleaner now to have like a dedicated configuration bean. Okay, let's continue. Well, let's do some health checking. Well, health checking important in a cloud-native environment, right? You want to give your your PaaS, your Kubernetes, your OpenShift, your whatever Pivotal Cloud Foundry the possibility to check if the system is up and running and healthy. So what we can do is, well, leverage the MicroProfile Health API. I'm going to implement a small health check here. So here we go. Always healthy check. So what do you have here? Well, first up, you need to implement a class which implements the health check interface. It needs to be annotated with the @health qualifier, and we make it application scoped. Now, of course, this health check here is not really intelligent, right? It always returns, hey, I'm healthy. So what you want to do here is maybe check your database backend availability, maybe your message queue availability. So you can do whatever you need in here. In reality, be careful in here. So I advise you not to do long blocking stuff in here, because then your health checks take quite a long time. And for the cluster operating system you're going to have later on, it's kind of important that this thing fires really quickly, because you want to query it quite often. So what you would usually do in a Kubernetes, for example, you would then have the health endpoint, which I'm going to show you in a minute, configured as a readiness probe, not a liveness probe, would be my suggestion. Okay, liveness probe. If your service is unhealthy, your service would be killed. For a readiness probe, it's just taken out of the load balancing. And if your database is not there, there's no point in restarting your service, because the database service is not there, right? So choose wisely what you want here. Now, you can have, of course, multiple health checks. So if I say health here, so you have like here the checks that I've done, and a status code of 200. So most of the cluster operating system out there, they expect status code 200, and if it's anything else, then they will assume, oh, it's not healthy, and then they will do what they have to do. Right, so this is health checks done. So how am I look on the time? Metrics integration. So let's add a few metrics. Adam used the gauge this morning. I think the gauge was, in my opinion, not the correct thing to use, but doesn't matter. You can use a gauge. So first up, I want to inject a counter. Okay, and I'm going to use it and I give it a name. And what you can also do is, we've seen different annotations you can put either on the class or on the method level to have like telemetry data, or maybe counting how often is something been called. So here you have the timed annotation, for example. Maybe if you come from a Spring world, there is, for example, Gemma metrics as a dependency, which you could use to do kind of the same. Now with MicroProfile, no dependency needed, everything out of the box. So I want all invocation of hello world to be timed. And I want this counter here to count the invocations. So what you can say here is counter.increment, and you're done. Kind of, you can do different countings. And you have histogram, you have the gauge, you have the plain counter. So there are quite a few dependencies in the MicroProfile metrics API. Right. So if you're going to issue this, then again, localhost metrics. So this is where Adam said, you're going to impress someone. The good thing is this format here is Prometheus compatible. So if you are going to plan, or if you plan to collect your metrics using Prometheus, then you're all done, right? A few annotations, and you've integrated into your metrics. So what you can do here is as well, you only want the application metrics, for example. So here, hello world counter, we've called it once. We have a few others here, right? So with not much work, just a few annotations, you get a full operational insight, okay? So your ops people will like you for that. Excellent. Well, documenting, right? So we heard Adam ranting about, useless, endless Swagger annotations and Swagger dependencies in your WAR file. Well, unfortunately, those times are over now. Again, if the app server you're going to use is like OpenAPI compatible, there is a default endpoint which you can issue, which is then OpenAPI, like that. Oh, no. And again here, you then have now an OpenAPI version 3 YAML file produced, right? Which you can then take to and put into UIs, or maybe give to some other clients who wants to access your service. Without any annotations, I think the app server or the API does a pretty good job. If you need to be more specific, then there are a few options which you can do. So if you, for example, want to give some general metadata, what you can use is, so let's see, So here's the contact import class, the info, and the OpenAPI definition. Yeah, in this case, what I've used, you see here, we have this magic file called packageinfo.java in this case, where there's only my package definition. And what I then use is the OpenAPI definition annotation, which I can put on packages, right? To specify, like, what's the title of my API, who's the context, what's the license. You can specify a few tags, the server, some external documentation. So several possibilities here. Good. And also, if you want, then on the method level, you can also have a few more specific annotations. Like you can specify the schema, which media types you're going to support, which response codes you have, like you have 200 or 404 and 400 for bad requests, for example. So you can kind of nicely document everything if you want to, right? So you can always customize the default behavior, which is also which is already pretty sane and good and sufficient. Okay, now we close others. Quick look on the watch. That's good. 15 minutes left. REST client implementation. So let's do something more sophisticated. So what I want is I want to implement a small web service that connects to the open weather map REST endpoint. So I'm kind of building a small proxy service for that, right? So I have this normal standard interface here, which I'm going to annotate with like the usually known JAX-RS annotation, like at get and at consumes application JSON. Query parameters I can specify. Also specify the path. The one thing that's important, I put in a new annotation which is called register REST client. So this will later on then be my way of interacting with the remote service. So no need to use REST builder anymore and use this more programmatic way. So I have a nicely typed way of interacting with remote REST clients. So we need some form of configuration. Always good. We add a Java class, and yes. Hop. We copy that one as well. This is almost like from Stack Overflow, right? So config property, provider, the correct one, add inject application scoped. Done. Yeah, we need an app ID to access the actual weather API, so that's kind of specific to the API. Now, next thing, I'm going to add a bean which I call Open Weather Map Repository because a class and a component should do one thing, and that should do it well. So all the technical details of accessing the remote API, I don't want this in my REST resource, so I'm going to use a separate class for this to do all this for me. And so let me quickly copy this stuff. So, and you see, wow, there are already quite a few log level, import, chrono unit. Yes, the correct timeout. I'm still not there. I'm going to use Lombok in case you're kind of a bit tired of typing too much, and maybe your POJOs, the getter setter, really suck. My suggestion is have a look at Project Lombok. It kind of saves you from this, boiler type thing where most people say like, oh, Java is so bloaty. Well, use Lombok, let the compiler generate the stuff for you, and you're done, right? And you're not distracted anymore. And Lombok plus JE, super nice combi. So have a look at the post construct initialize method first, right? So what we have here is we're going to say REST client builder, new builder. We specify a base URI, and then we're going to say build, and we use the interface we just created. So this typed interface we're going to use in here, right? See here, because this method here does a remote call, it's always good to specify a circuit breaker. So we have for our resiliency, I specify a timeout of 3 seconds in this case. I want to specify a fallback method, which I call default weather in this case, and I want to cache all the results from this method. So the current weather, I want to cache for maybe 30 seconds, because Open Weather Map API does not allow more than, 30 calls a minute, for example. So it's always kind of good practice to cache this value, right? I mean, the weather in Munich or here in Düsseldorf is not going to change that often, or at least not every minute. So I can cache that for quite some long time. Now what I've done, there's one class missing, which I'm going to create now, okay. So we're going to say current weather, create current weather. We do that here, yes. Oh God. There's a slight glitch in my demo. Private string city, private string data. Hop. Going to use add no args constructor, add all args constructor. Okay, this is a bit of Lombok magic. You see, this is what a POJO in the year 2018 should look like. I mean, under the hood, all the getters and the constructors, it's all generated for you, right? So a few annotations and just specify the fields, and there you have your POJO. So what do we have here? For example, I'm going to use like, CDI events to kind of broadcast and fire the async. So let's see if that is working. So what we want is, we want to have API slash weather slash Düsseldorf DE. Ta-ta, so the weather is clear. What you see up here is, well, in here we have this line of, can you see that? That's kind of blurry, but this is like the JSON response we received from the previous, well, from this REST call in that case. So that's the JSON response. And maybe what you haven't seen, what I do, for example, is I use a JSON pointer, for example, to only extract a certain part of the JSON message, which I received. And this is kind of also good practice. Maybe you've heard of the tolerant reader pattern, right? So be liberal in what you accept. And again here, JSON-P APIs from Java EE makes this really possible really nicely, because in the end I don't care about the real structure of this JSON object that comes back there. I'm only concerned in, well, the weather node, the first index, and the element main. This is all I'm interested in, right? So I'm only extracting this certain part of information. And this kind of is some form of loose coupling, right? If they're going to decide, well, we kind of have extra elements there, and kind of they do API evolution, for example, the possibility that my client breaks is rather low, because I'm only extracting this certain part, okay? I'm only relying on that one. That kind of brings me to, maybe we do a quick sidestep. Topic versioning, right? Versioning will come at you at some point. You implement your microservice, you add new features, and at some point you have to version your interface, right? You have to version. You need to introduce some breaking change. How do you do it? Well, there are always the two possibilities, right? You can have like URL-based versioning. You introduce a V1 and a V2 into your path. Like the REST purists, they would die now. They say you need to use media types and something called content negotiation. I mean, pick your own poison, but I think content negotiation is super neat, and it works like a dream in Java EE. So what you see here is you have two methods. The one is called V1 and it's called V2. This one here produces application JSON or a specific media type which I created myself, right? And I introduced a new version which will be, well, provided if I'm going to send the right media type, if my client sends the right media type. So this type of versioning you see here is, for example, applied by GitHub. If GitHub introduces a new REST API, what they do? Well, they introduce the new version, they introduce a new media type. All the old clients, they don't break because the old functionality is still there, and the new clients, they can use, by specifying the accept header, this new API, right? Let us see why we have that. So if I do like API version with accept application JSON, for example, right, I get V2. If I specify app version with the specific V1 type, of course I get V1. The default version, I don't specify any headers. I get V1 also because in my content negotiation, this one has the higher factor. So this is the preferred preference. And for V2, I say accept, and I send here. So maybe in the next microservice you're going to implement, maybe choose media type-based versioning instead of URL-based versioning, and JE is your friend here. Right, 6 minutes. Ooh, that's gonna be tight. So we go back here. Well, the one thing I want to show you is asynchronous APIs, right? So far, the Hello World resource has been asynchronous REST resource. But what you can do for long-running things, you can use asynchronous capabilities of JOXRS in this case. So let's see. So this is application scoped here. So we have an application scope bean at path weather. We're going to inject our weather repository. We're going to import a class. The media type produces, is that the right one? Yes. API response, oh god. So the first thing now here is the first parameter which you're going to see here. We say add suspended async response. So this is kind of my callback object which I'm going to need. So we have like here, oh god, that's probably that one. We're going to delete, and here we have the path parameter. So whenever there's a request inbound for this REST resource, what it's actually going to do is it's going to take the acceptor thread and takes the request and the response and puts it on a separate thread pool. Okay, so your acceptor threads of your app server are not blocked by any long-running stuff. And again, here you can specify a timeout for this explicit thread. You can specify what should happen if you have a timeout. So you specify the timeout handler, and you have this response here. So response resume, and we're going to issue the get weather for this one. So again, here, if you want to have asynchronous REST APIs, it's quite easy to do with Java EE. So think about the resource efficiency, right? Yeah, that's a good question. We have to try it out. We can do it maybe later on what exactly happened. But my point of view would be if you have like separations of concerns, I would say a circuit breaker annotation at that point at the REST resource is the wrong place to do. I mean, it's kind of a lazy answer maybe to avoid your question, right? A metric is a good one, right? Well, let's see, timed, we do it. I do this now, I finish the demo, and then we see what's going to happen, right? So, finally, what I want to show you is, and we have 3 minutes left, and that's going to be tough. I'm going to show you server-sent events. It's kind of a nice feature as well. So how do you do push communication with your browser? That's the question. Well, you could use WebSockets. WebSocket programming is kind of tedious a bit. It's not so hard, but there's something simpler, and this is called server-sent events for pure server-side push communication with maybe a UI. So we're going to add, so with this is here a resource. So I timed logging. Now this is a lot of code and a lot of imports. I've got this working anyway, so to speed things up. So the most important bit here is this server-sent event broadcaster. So I'm going to use this one to interact with all the connected clients with the broadcaster. And here I'm going to inject the server-sent event at context, right? And also I'm going to use the repository we just implemented. So we're going to do that. Well, the next thing here is this is the connect method, right? So every time someone connects and sends this specific media type here, the server sent event media type, then we can kind of memorize the connection we just received. So we have add consumed, we have metrics, we have the response. Here we have an add not blank annotation to have like parameter validation on this form parameter, for example. So the city should be not blank. Here we have a gauge, for example. And here we have like the receiving side of the current weather to JSON. Well, we do that. We don't do that now. Okay. And if you want to broadcast something to your connected client, what you can do is you create a new event builder, you give it a name, you specify some data, you specify the media type. So in this case, we want to send JSON, for example, and then you use the SSE broadcaster and you say broadcast of this event, right? And all the connected clients will now be pushed this information if they're still connected. Again, what we need is, well, we need a JSP file, and this is kind of the final bit, and then I'm going to wrap up. So, where is it? Webinf, create. Where's my JSP file? There it is. JSP. Index.jsp. Yes. Up. Okay. So the main part here is this script element. Okay. So this is all you need. You construct a so-called event source. So a bit of JavaScript magic here. You add an event listener, and this will be now notified anytime there's a new weather event. So to show you that things are working, here's my page. Let's see what the weather in Munich is like. And the weather is in Munich, right? So this fires off a post request, and the server now sends back via push communication the current available weather. Right, time is up, so time to wrap up. Just one more slide. So yeah, this is some stuff about JSON-P and JSON patch. Right, if you're interested, I kind of wrote a book and did a video, and I'm currently doing another video as well. So if you want to have a 50% discount code, make a picture now, right? I will post the slides on Twitter later on. Yeah, I hope you had some fun during this session. If you're looking for a job, maybe, then apply and talk to me. Thanks for your time, and I hope you enjoyed this session.